It's time for us to go over how a resistor in a circuit works in alternating current. In this video we'll be finding the RMS current, the peak voltage, omega, and the voltage, current, and time at phase angle of 60 degrees. Let's first find the RMS current. The RMS current can be found by rearranging Ohm's law to be V over R. So if we take our 120 volts over our 500 ohms, we get 0.24 amps. Now we need to calculate the peak voltage. The peak voltage can be calculated by taking the square root of 2 times the RMS voltage. So if we take the square root of 2 times 120, we get 170 volts for our peak voltage. Now we need to find omega. Omega is basically how many radians or how many degrees a second the sine wave is moving. So to complete this, we have to know that a wall socket comes at 60 hertz or 60 cycles a second. So now if we take 60 times 360, because there's 360 degrees in a complete circle, or 60 times 2 pi, because there's 2 pi radians in a circle, we will get what our value for omega is. In this case, our value for omega is 21,000 degrees a second, or 120 pi radians a second. So now we need to find the voltage at a phase angle of 60 degrees. We can do this by timesing the voltage peak times the sine of 60 degrees. So when you're completing one of these problems, you can think of the voltage peak as a radius or the hypotenuse of a triangle. So really what you're doing is you're taking the sine times the hypotenuse to get what your voltage is at a given point in time or at a given degree. So now to figure out what time you'll reach the 60 degrees phase angle, so now you can take your 60 degree phase angle over omega, or how many degrees a second the sine wave is traveling at. And in this case it's 0.00277 seconds from the point in time in which you hit the on switch, assuming that you start at the beginning of a sine wave. That concludes this video. Thank you for watching.